Hi everyone. Today we're going to go ahead and review the 4 methods for solving quadratic equations that we've talked about in class so far. We're going to go ahead and start with graphing, and we're going to graph the function x squared minus 8x plus 15, and we're trying to identify where that function equals 0. In other words, when we're solving this equation by graphing, we're looking for the x-intercepts. We learned how to do this both in Desmos and on our graphing calculator. I'm going to do it on my graphing calculator just as a quick review for you on how to use your school-issued TI-84. So here on the right, you can see my digital version of the calculator that you guys have. So remember that when we want to enter an equation in our calculator, we press the y equals button underneath our screen. So it's in the upper left-hand corner. And then we type our formula. And to pull up that x variable, we hit the xt theta n button right here, right next to the green alpha. So x squared minus 8x plus 15. I'm not entering the equals 0. I just want the function part of that equation, just the quadratic function. To graph it, the easiest way is to go zoom and then select Z standard, which is option 6. And then we're going to press enter. And we can see both solutions on our graph. So looking carefully, we can see that we've got an intercept at 3 and an intercept at 5. So the solutions to this equation are x equals 3 and x equals 5. I can also see that the vertex is at x equals 4 and y equals minus 1. So that gives me enough information to really quickly sketch my graph. So I'm going to go ahead and do that here and then state my answers. So let's go ahead and mark those important points. We know we have solutions at 1, 2, 3, and 5. And then we know that our vertex is here at x is 4, y is negative 1. And so we end up with a graph that looks kind of like this. Yours might look a little prettier. And then we're going to write our solutions. X equals 3 or x equals 5. I can also see that by factoring, and we're going to practice that method in just a minute, but I know that 3 times 5 is 15, and 3 plus 5 is 8, so I know that's where that's coming from. So I know that this is actually going to factor into x minus 3, x minus 5, and that's where those intercepts are coming from. But let's go ahead and try the next one, which is an actual factoring problem, so we can see the whole factoring process in one go. So we have the function x squared minus 12x plus 32, and we want to find what x values make that statement 0. So first thing we want to do is write this in factored form, and to do that we're going to play our x game. So we're going to write our C in the top box and our B in the bottom box. And then we're looking for numbers that multiply to 32 and add to negative 12. And because 32 is positive, I know these signs are the same. And because the bottom's negative, I know they're both negative. So two numbers that multiply to 32. I happen to know that 4 and 8 work. 8, 16, 24, 32. So 4 times 8 is 32, and 4 plus 8 is 12. So that does work out. So this function is x minus 4 times x minus 8. And we're going to set that equal to 0. And using the 0 product property, we know one of these two binomials must be 0 if our answer is 0. So we get two separate equations. We get x minus 4 equals 0, or x minus 8 equals 0. And we're going to go ahead and solve those equations for x. So to undo this subtraction of 4, we're going to add 4 to both sides of this equation. Over here on our second equation, to undo that subtraction by 8, we're going to add 8 to both sides. And then let's see what we get. So on this equation here, those 4's are going to cancel. They're a 0 pair. And we get x equals 4. And over here in this second equation, the 8's also cancel. They're a 0 pair. And we get x equals 8. And you'll notice, just like we saw in our graphing problem, what we see in factored form and what we see as our solutions flip signs because of this solving process that we go through where we set them equal to 0. Okay, let's try another one. The next method is the newest method. That's the quadratic formula method. And I know that's a little intimidating, so let's go through this one nice and slow. The very first step to using the quadratic formula is to identify A, B, and C. So looking at this equation, over here to the side, I'm going to write what my A, my B, and my C are. So A is the coefficient on the x squared term, so that's a 2. B is the coefficient on the x term, which is a minus 5. And C is the constant at the end, which is a positive 3. And our next step is we're going to go through this formula. You can see it written up here. And we're going to substitute these values in. So this equation says minus b, and we know our b is minus 5, plus or minus the square root, big long square root, of b squared, so I'm going to plug b in, minus 4 times a, which is 2, times c, which is 3. And all of that is over 2 times a, which is 2. From here, we're just going to do some simplification. We're going to simplify each small part of the formula until it's something that we recognize. So negative is going to become positive. So positive 5 plus or minus, and then under that square root, I know that negative 5 times negative 5 is positive 25. And I know that negative 4 times 2 is negative 8. And negative 8 times 3 is negative 24. And then in the denominator, I know 2 times 2 is 4. And so I'm going to go ahead and simplify this a little bit further right here. I know that 25 minus 24 is 1. So that got a whole lot prettier. So now we're left with 5 plus or minus, and we know the square root of 1 is just 1 all over 4. Now that we've gotten rid of that square root, everything's been simplified down to nice pretty whole numbers. We're going to split this into two answers, one with the plus and one with the minus. And remember, we expect two answers because more often than not, our parabola crosses the x-axis twice. And so we get two different answers for those two different x-intercepts. So first, the positive 5 plus 1 over 4. And then the second one is going to be the subtraction, 5 minus 1 over 4. So 5 plus 1 is 6. So 6 over 4. I happen to know 6 and 4 are both divisible by 2. So that's going to become 3 over 2. Or if you're on your calculator and you gave me 1.5, that's also okay. For the bottom one, 5 minus 1 is 4. And we know that 4 divided by 4 is 1. So for this quadratic equation, 2x squared minus 5x plus 3 equals 0. Our solutions are x equals 1 and 3 halves, or 1.5 if you like that better. The quadratic formula is useful because this particular equation has an a in front, so it's going to be difficult to solve by factoring, and one of our answers was a fraction, which we know we don't typically get when we factor things that are nice and pretty. We also know when we have decimal answers, those are sometimes harder to pick out of a graph. So the quadratic formula is really powerful when none of the other methods on this page work. Our last method is the square root method. And this method we only use when we have equations that can be written as x squared equals a, or x plus a number. So x plus, I don't know, b squared equals a. The first one we've seen when we took our notes, we talked about the square root method. We've got 4x squared plus 1 equals 325. I don't have a middle term. There's no x term, so this is a good candidate for the square root method. And I want to get the x squared by itself. I want to isolate this thing here. So we have to undo the stuff around it. So we're going to start with undoing that addition. Right? We work PEMDAS in reverse. So we subtract 1 from each side, and we get 4x squared equals 324. The next step, we have to divide out that 4. That's how we get rid of coefficients. We divide. So both sides get divided by 4. And that's going to cancel those 4s and leave us with x squared equals, and then I need to pull up my calculator really quick and check what is 324 divided by 4. 81. So x squared equals 81. All right, our last step. To undo that squared, we take the square root, which is why this is called the square root method. The square root of a square, they undo each other. We get x equals. On the right, anytime we take the square root of a number, we pick up a plus or minus. And we know the square root of 81 is 9. So the solution to this first equation is x equals plus or minus 9. So this graph is going to be nice, pretty, and symmetric about the y-axis. If we were to sketch this, it would be nice and pretty with the vertex sitting on the y-axis. And then those x-intercepts would be at minus 9 and plus 9. Now we're going to try the same process with something that looks a little bit different. X plus 5 squared equals 64. And this looks kind of similar to vertex form. So oftentimes if we're given an equation that looks like vertex form, the square root method is a great way to go because we know that we can undo that square with a square root. So that's how we're going to start this second problem. Let's take a square root of both sides. And we know that square root undoes the square, so we get x plus 5 equals. And on the other side, we get a plus or minus. And I'm pretty sure the square root of 64 is 8, but I am a little sick, so please check my math. And then from here, we want to get x by itself. So we need to undo that plus 5. We're going to subtract 5 from both sides. On the left, we get a 0 pair. Those 5s go away. And on the right, we get something a little weird. Anytime you've got a number with a plus or minus, we tend to write that at the end of an expression. So I'm going to write the negative 5 first, and then plus or minus 8. And just like with the quadratic formula, when you have a plus or minus in your answer, you need to split it into two pieces. One for the plus, one for the minus. So our two answers are going to be negative 5 plus 8 and negative 5 minus 8. So negative 5 plus 8, I happen to know that that's 3. And negative 5 minus 8 is negative 13. So the two answers for that second equation are 3 and negative 13. So this parabola, if we were to graph it, is not centered about the y-axis. This one is heavily skewed in this direction, with its vertex somewhere over here. So that if we were to look at those intercepts, one of them is at positive 3, the other one is at negative 13. Okay, so that was a review of everything that we have talked about in this first chunk of Module 1. You've got the rest of the period to work on a mixed review assignment. When I see you on Friday, we're going to go ahead and do some practice together and then take a team test. And then on Monday, you are taking a test on solving quadratic equations so that we can continue on with the rest of Module 3. If you have any questions, let Ms. Nieves know or shoot me an email, and I will see you on Friday.